Yes, today we look at oxidation states and most of the oxidation states relating to oxyacids. Look here, some elements have fixed oxidation states. Who are they? Elements of 1A, lithium, sodium, potassium, rubidium, cesium, francium. I repeat, lithium, sodium, potassium, rubidium, cesium, francium, which are called alkali metals. They always have a fixed oxidation state of +1. What I mean to tell you, in any compound they are always taken as +1. And elements of 2A, beryllium, magnesium, calcium, strontium, barium, radium, they always have +2. And fluorine always is -1, the oxidation state. So, with other elements, you can have any oxidation state. That is, for example, PCl3, the oxidation state of phosphorus is +3, PCl5, the oxidation state is +5. So, if I ask you what is the oxidation state of phosphorus, you can't say unless I mention what compound I am talking about. So, they have variable oxidation states. These set of elements, only these elements have rather fixed oxidation states. Okay? So, I repeat, 1A, 2A fluorine, and of course, there are one or two other elements, aluminum +3, zinc +2, some one or two other elements are there. Don't make this list too long. It is enough if you know some elements have fixed oxidation states and some others don't. Most of the elements don't have fixed oxidation states. First point, fixed oxidation states. Whoever has fixed oxidation state. Second point, if oxygen gets 2-, oxygen -2, then it is called an oxide. I repeat, oxygen 2-, it is called oxide. O2 2-, two oxygens put together 2-, or one oxygen just 1-, O-, or an oxygen single bond. This is called oxygen single bond. This is called a peroxide. A substance containing oxygen single bond is called a peroxy compound. So, how to identify a peroxy compound? You should get the oxidation state of oxygen as -1. Each oxygen should get -1. Two oxygens put together, they should get -2. And if two oxygens put together get minus or -1, or each oxygen -half, then it is called a superoxide. Superoxide, oxide, peroxide, superoxide. Let me look at some examples. What is the name of KO2? KO2. What would be the name of KO2? Is it potassium oxide or potassium peroxide or potassium superoxide? How will we go about the job? Potassium always has a fixed oxidation state which is +1. Two oxygens together, they get -1. You know, the total should always be 0. If this is +1, both the oxygens should share -1 to give you a net 0. So, each oxygen you are getting a -half. So, oxygen in which you get -half is called a superoxide. Therefore, what is the name of KO2? KO2 is potassium superoxide. Potassium superoxide. Why do I call it a superoxide? Because oxygen is -half. Why is oxygen -half? Because potassium +1. Why is potassium +1? It is always +1, fixed. So, if you have an element with fixed oxidation state, it is very easy for you to deal with things. What about BaO2? You remember elements of 1A +1, 2A +2. What are the elements of 2A? Beryllium, magnesium, calcium, strontium, barium. Barium fixed +2. So, barium here is fixed +2 and two oxygens -2 and each oxygen -1. So, each oxygen -1, Here it is the sum of the oxidation states of both the oxygens, 2 oxygens minus 2, each oxygen minus 1. Therefore, this is called oxygen minus 1. It is called barium peroxide. What is important? Peroxide is important. Peroxide. How do I know it is a peroxide? Oxygen is minus 1. Why is oxygen minus 1? 2 oxygens together are getting, collectively they are getting minus 2. Why are they getting minus 2? I have not given minus 2. I have not given this. They got minus 2. Why? Barium is plus 2. Why is barium plus 2? Fixed. In any compound, you can simply close your eyes and say barium, wherever it is, always plus 2. Of course, in a molecule. In a molecule, barium, or the role of barium is always loses 2 electrons in any molecule. So, it is very easy to understand now. So, what about MnO2? Is it an oxide or a peroxide, or what is the oxidation of manganese here? Manganese is neither fixed, and we are not sure whether oxygen is 2 minus or minus 1 or minus of. Oxygen I have already given 3 choices. If oxygen is 2 minus, it is called oxide. If oxygen is minus 1 or 1 minus, it is called peroxide. If oxygen is minus half, then it is called a superoxide. So, how much is oxygen here? We don't know. How much is manganese? We don't know. So, when there is an element with fixed oxidation state, for example, OF2, what are you sure about oxygen? Very sure about oxygen. Fluorine is minus 1. So, minus 2 plus 2. The oxidation of oxygen is plus 2. Why is fluorine minus 1? 2 fluorines minus 2. Why is fluorine minus 1? Fixed. Wherever you see fluorine, you can simply say fluorine is minus 1 and enabling you to give minus 2 plus 2. Right. So, when there is an element with a fixed oxidation state, thank your stars, the question is easy. If there is an element with fixed oxidation state, you are lucky and you can easily conclude. You can come to a conclusion very easily. And then, maximum oxidation state that could be taken by any element is equal to its group number. And for this rule, only copper is an exception. Copper is a very chief exception. Copper, Cu is an exception. Oxygen, fluorine, iron to some extent. I am not writing big letters because I am not giving importance to them. Copper belongs to, if you remember well, copper belongs to 1b of the periodic table. Copper, silver, gold. You will come across them in the D block. Okay. So, what should be the maximum oxidation state of copper? According to this rule, copper should only be plus 1 because group number is 1. But copper, you know, exhibits an oxidation of plus 2. Therefore, this is an exception. Oxygen belongs to 6A of the P block. Its maximum could go as high as plus 6. But oxygen never exhibits that. But it is permitted to exhibit. So, it is permitted, but it is not using the opportunity. And iron belongs to 8th group. It can exhibit as high as plus 8, but iron is not using that opportunity. So, strictly speaking, these are not exceptions, but copper is definitely an exception. Once again, maximum oxidation state is equal to group number. Let me give you at least 1 or 2 elements of each groups. 1A, 2A, 3A, 4A, 5A, 6A, 7A. It's very important that you know. You have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So, when I ask you what is the maximum oxidation of sulfur, sulfur belongs to 6th group, plus 6. Chlorine belongs to 7th group, maximum plus 7. Phosphorus belongs to 5th group, maximum plus 5. Silicon, maximum plus 4. Aluminum, maximum plus 3. Don't worry about 1A, 2A, they are plus 1, plus 2 and fixed. They are always. So, don't worry about 1A and 2A. Maximum oxidation state is equal to group number, for which copper is an exception. So, for example, you have scandium, titanium, vanadium, chromium, manganese, 3B, D block, 3B, 4B, 5B, 6B, 7B. Yes, pronounce the oxidation states. Maximum of scandium plus 3, titanium plus 4. Why? Group number. Whether it is A group or B group, it doesn't matter. For A group and even B group, plus 3, plus 4, plus 5, plus 6, plus 7. You got my point? So, maximum oxidation state is equal to group number. This is a very, very important rule. And minimum oxidation state is equal to group number minus 8. But this is for 4A to 7A only. This is for 4A to 7A only. That is starting with carbon, nitrogen, oxygen, fluorine, only these 4 groups, carbon family, nitrogen family, oxygen family and fluorine family of the P block. You know that our main intention is to discuss chemistry through P block. P block where you find non-metals mostly non-metals. So, what is the maximum of carbon? Obviously plus 4 because this belongs to 4A group. 4A, 5A, 6A, 7A, right? So, carbon maximum plus 4, minimum minus 4. How do you get it? Group number minus 8. Plus 5 is maximum. Plus 5 is maximum, minus 3 minimum, plus 6 minus 2. But of course, oxygen I told you, it doesn't exhibit an oxidation state of plus, right? So, here you are. Sulfur, maximum 6th group plus 6, minimum minus 2. Phosphorus, 5th group, maximum plus 5, minimum minus 3. So, what is the rule? Group number minus 8. Chlorine, 7th group, plus 7, minimum minus. So, there are very interesting uses of oxidation states, among which I tell you a little later. Oxidation states are very, very, very important. So, in the absence of fixed oxidation state, who are they? Fixed oxidation states. In the absence of fixed oxidation, that is 1A, 2A, fluorine and a few others. In the absence of fixed oxidation states, you try and give minus 2 to oxygen. You try and give minus 2 to oxygen. It is only a trial and error. When you give minus 2 to oxygen, if the other atom, if the other atom gets impossible oxidation state. What do you mean by impossible? Impossible oxidation state. What do you mean by impossible? Higher than the group number. Higher than the group number. If somebody gets impossible oxidation state, then it is a peroxide. Means that substance contains oxygen single bond. I repeat this statement, be careful. In the absence of fixed oxidation state. Why are we talking about in the absence of fixed oxidation state? Because we know when you have fixed oxidation state, there is nothing for us to do. If you have fixed one, happy, the problem ends immediately. So, in the absence of fixed oxidation state, you try and give minus 2 to oxygen, and if the other atom objects to it, if the other atom says, I am sorry oxygen, I don't permit you to be minus 2, then it is a peroxide. Okay? Let us look at examples. So, there are only 2 things you should take care of now. Fixed to oxygen, from fixed to oxygen and from oxygen to others. KO2 plus 1 fixed, find oxygen from that, minus 1 minus off. Here fixed element to oxygen, and in others MnO2 give minus 2 to oxygen, you will get minus 4, manganese plus 4. And is manganese unhappy being plus 4? Why should it be? Is manganese unhappy to lose 4 electrons? It never is. Manganese can lose as many as 7 electrons because manganese belongs to 7th group. The maximum is plus 7. I forgot to tell you, from 4A to 7A I said a rule for minimum oxidation state. Do you remember? What is the rule for 4A to 7A? Group number minus 8. What about others? Starting 3rd group, 2nd group, D block. What is the minimum for manganese? What is the minimum for aluminium? What is the minimum for magnesium? What is the minimum for so many transition elements, F block metals? transition D block metals, F block metals, S block metals. And in the third group, apart from this third group, you just have boron, and other than boron, all others are metals. And what will be the minimum oxidation state of a metal? Metals never exist in negative oxidation state. You must never have seen sodium in -1 state. Means sodium gaining an electron, that is meaningless. So the minimum of all others is obviously 0. That's why I did not mention. This rule looks to be too simplified. Why? The rule is only for 4A to 7A. You will always get a doubt, what about remaining 14 groups? There are 14 groups, 14 other groups, total 18 groups are there. So what is the minimum oxidation state of all others? Except these 4 groups, all others minimum is 0, because all others are metals. Okay? So MnO2 is not a peroxide, it is an oxide. Now you look at this molecule HClO4. Does it contain an oxygen-oxygen single bond, which is called a peroxy bond? So what will be the question? Which of the following has a peroxy bond? Why are we interested in this peroxy bond at all? Okay, a substance contains peroxy bond. So what? Don't take it so easily. If a substance contains peroxy bond, the peroxy bond is a very, very, very weak bond because of the presence of too many lone pairs, and the bond breaks easily. So what? You will get an oxygen atom freely. Oxygen atom free. So substances with peroxy bond, they provide us the moment we want an oxygen atom, which you call nascent oxygen atom. Substances with peroxy bond, hydrogen peroxide, it is a very interesting molecule. It has an oxygen-oxygen single bond, which is a very weak. Why is it very weak? Because of the repulsions experienced because of too many lone pairs. You have 4 lone pairs here. So the bond is weak. So H2O2, it gives you oxygen, and a substance that gives you oxygen, it is quite interesting. H2O2 gives you oxygen very, very easily, a nascent oxygen atom. Suppose a substance gives an oxygen, bacteria dies of oxygen. Very interestingly, we human beings live of oxygen and bacteria dies of oxygen. So you can use H2O2 as an antiseptic which kills bacteria. How is it used as antiseptic? Because H2O2 has a very weak bond, weak oxygen-oxygen single bond. I insist, oxygen-oxygen single bond, which is called a peroxy bond. So what way that is interesting? H2O2 is a substance that simply gives you an oxygen, and oxygen kills bacteria, purifies water by killing bacteria. You can use these substances as water purifiers, antiseptics, and most interestingly, this oxygen atom will remove colors of vegetable substances, vegetable matter, so bleaching agents. So H2O2 is a bleaching agent, H2O2 is an antiseptic, H2O2 is, it can be used as a water purifier, but we don't use, because H2O2 is an acid also. H2O2 is an acid also, we don't use it as a water purifier. Right. So HClO4 -8. I didn't say anything about hydrogen because it's not necessary. Hydrogen most cases is +1, except when it is present with metals. It is without metal hydride, MH, metal hydrogen, metal is always plus, therefore hydrogen is always -1. So what about hydrogen? Either +1 or -1. Most of the cases hydrogen is +1. So what is chlorine getting here? +7, because the net should be 0. You should always have that in mind, the net will be 0. So 4 oxygens, 4 into -2 -8, hydrogen is +1, chlorine is getting +7. Does chlorine mind being +7? No, not at all. Why? Chlorine can go as high as +7 maximum. So this is possible for chlorine. What do you mean by possible for chlorine? Chlorine has no objection to go to a +7 state. So here oxygen can happily become -2. Therefore this is not a peroxide. This is not a peroxy substance. What is that? This is not a substance that contains a peroxy bond. OO single bond is not there. And moreover, we know the structure. 1 chlorine, 1 OH, 3 more oxygens which are forming 2 bonds each, right? So where is O single bond O? There is no oxygen-oxygen bond at all. So instead of drawing the structure and finalizing that there is no O single bond, even without this structure, just look at it, -8. So H3PO4, does it contain a peroxy bond? H3PO4, -8, 3 hydrogens plus 3. What did I tell you about hydrogen? Most of the cases it is +3. With metals, it goes without saying hydrogen will be -1 because metals are always electropositive. For example, you have sodium hydride in which Na is plus, H is minus. That is why it is called hydride. Hydride, IDE, IDE. The sound IDE, the suffix IDE will always tell you it is an anion. Chloride, Cl minus, bromide, oxide, nitride, carbide, phosphide. IDE means minus. IDE. So, here you are H3PO4 -8, hydrogen 3 hydrogens plus 3, phosphorus gets +5, phosphorus is happy. So, when here if you get an impossible oxidation state higher than 5, then I might have thought otherwise. But here I don't, oxygen need not change his mind. Oxygen says, I want to be -2. I want to be -2. What will others say? I want to be -2. Here phosphorus and other people say, okay, you be -2, we have no objection. When will they object? When they are made to pay more than their capacity. Here phosphorus can pay 5 electrons and it is paying 5 electrons, losing 5 electrons. Suppose phosphorus is made to pay more than 5, then they will request oxygen, please oxygen change your state. Change your, bargain will be there. KMnO4, -8, 4 oxygens, potassium +1, manganese +7. Manganese here is asked to lose 7 electrons and manganese is happy losing 7 electrons because it can go as high as +7. Getting my point? So, manganese has no objection. Then why should you have any objection? So, KMnO4 +7, therefore it is not a peroxide. You don't have a peroxy bond. Not a peroxy bond. O single bond is not there. And you know pretty well K plus MnO4 minus. How to draw the structure? 1 manganese, 4 oxygens, right? One of them is a minus. O minus forms 1 bond. This is what we taught in our first lecture, how to draw structures. 1 manganese, 4 oxygens, one of them is a minus. O minus forms 1 bond. Oxygen, wherever it is, it forms 2 bonds. So, show me where oxygen single bond is there. It's no longer there. What about Na2O2? Would it be a peroxide? Would it be a peroxide? Check. Fixed, sodium fixed, +2. 2 oxygens, -2. Each oxygen, -1. Each oxygen, -1. Or O2, 2 minus. These both will indicate this is sodium peroxide. Sodium peroxide. There is an interesting situation here. Between Na2O and Na2O2, there are 2 compounds, only 2 choices you have. Which will turn red litmus white? Think about it. Red litmus white. Ever heard of this? Red litmus blue? Bases do that. Red litmus is turned blue by bases. Red to blue by bases. But what is this red turning white business? Red turning white. Decolorization, bleaching. Who will do? Between these two, who will turn red litmus white? Somebody who can bleach. I told you peroxy compounds have an extra oxygen and they can turn red litmus white, means they act as bleaching agents. So, this is the answer. Na2O2 being a bleaching agent. How do you know it's a bleaching agent? It has an oxygen single bond. So what? Oxygen single bond is weak. So what? It breaks easily. So what? So, always you should ask yourself, so what, so what, so what? And now you will reach the end of the topic, right? Na2O, red litmus turned white. You will understand the question. Now, CrO5. Comment on this. CrO5. 5 oxygens -10. and chromium is made to lose 10 electrons. Is chromium ready to do that? Plus 10? Impossible. Chromium, the maximum is plus 6 starting with 0. So 10 is impossible. So I have given oxygen as minus 2, but chromium says I am sorry, I can't lose 10 electrons. Therefore, oxygens will change their demand. Okay, they will accept their bargain. So this is a peroxide. How will you draw the structure? Peroxy means oxygen single bond. Okay, and how many peroxy bonds are there? Number of peroxy bonds. Number of peroxy bonds is equal to impossible oxidation state, impossible minus maximum by 2. What is impossible you got here? 10. Why is 10 impossible for chromium? Chromium, which belongs to 6b of the periodic table. 6b cannot have more than plus 6. So it is 10 minus maximum. Maximum possible is 6. 10 minus 6 by 2. So you have 2 peroxy bonds, oxygen single bonds. 2 peroxy bonds. So how will you draw the structure? Chromium at the center, 5 oxygen surrounding, and what is it you have just learned a few minutes ago? It has 2 peroxy bonds. OO single bond, OO single bond. Oxygen forms 2 bonds. Oxygen forms 2 bonds. 1 is already there. What is it you end up getting? You have got the structure of a butterfly. You should not calculate oxidation states from the structure. Moreover, you have to draw the structure from oxidation state. It is not structure to oxidation state, but it is oxidation state to structure. This is wrong. From the value of oxidation state, I could draw the structure. I repeat, CrO5. What is the speciality of CrO5? Minus 10, 5 oxygens demand minus 10, plus 10, which is impossible for chromium. He says, I can't give more than 6. Okay. So 4, there is a shortage of 4 electrons, which 2 oxygens share between themselves. 2 oxygens share between themselves, leaving behind a double bond. Oh, you got the butterfly structure. So draw the structure of XO3. X belongs to 4A. Draw the structure of XO3. X belongs to 4A. If you understand this question, you learn too many things. X belongs to 4A means maximum plus 4. Maximum plus 4. X, the maximum oxidation state is plus 4. It can't be more than 4. So here 3 oxygens they demand. X belongs to 4A. I already told you. Minus 6 plus 6. Plus 6 is impossible for X. Why? Why is plus 6 impossible for X? X belongs to 4A. Maximum it can afford is plus 6. Therefore, you have, so there is 1 peroxy bond. So 1 X, 3 oxygens, and there is oxygen single bond. How do I know? Peroxy. When you get impossible like this, it's a peroxy. Oxygen forms 2 bonds. There ends the matter. Now, H4P2O7, does it contain peroxy linkage? Let us check. 7 oxygens as usual minus 14. 4 hydrogens plus 4. 2 phosphorus are getting plus 10. Each phosphorus gets plus 5. It is okay with phosphorus. How come? Phosphorus belongs to 5th group. Phosphorus belongs to 5th group and it can afford plus 5. Therefore, here you are. Plus 10 is possible. Therefore, no peroxy. No peroxy. Next, let us check another molecule. H3PO5. Does this contain an oxygen single bond, which is called peroxy bond? How to check? H3PO5. 5 into oxygen minus 10, plus 3, plus 7. Once again, impossible. Why is it impossible? Phosphorus maximum plus 5 only. So what is most important? You should know the group number of certain elements. At least phosphorus, nitrogen, oxygen, sulfur. So at least second, third period elements you should know their group number. Second period, third period, and the 3D series. Scandium to zinc is important. So 3B to 3b, 4b, 5b, 6b, 7b. It is the old notation, Roman number. Don't use the present system 1, 2, 3, 4, 5, 6, 7. Don't use these numbers suggested by UPSC. They are no good to us, because they say chlorine belongs to 17th group. What fun is there? Chlorine belongs to 17th group means, will it have a maximum oxidation state of plus 17? No. The rule we derived from the old group. Old groups are 1A, 1A to 7A, 1B to 7B, and of course 3 8 groups, 8 8 8 3 8 groups, and 3 8s and 1 0. So this is the old notation, follow that only. So it contains a peroxy bond. Peroxy linkage is there. Why did I say that? Because I got plus 7 for phosphorus, which is impossible for phosphorus. Right. So H3PO5, what should he do? 1 phosphorus, 3 OH, H3PO5. How to draw the structure? You already have 1 phosphorus, 3 OH groups, and a double bond O, and a OOH. Why did I write OOH? Because I know it is a peroxy compound. What is peroxy? OO. It is peroxy. Peroxy means OO. How do you know this is peroxy? Phosphorus is getting impossible of plus 7. Right. Next. H2SO5. Does it contain? So, what is the name of H3PO5? Yesterday we discussed peroxyphosphoric acid. What did you call that yesterday, if you remember? Peroxyphosphoric acid. A little too many oxygens. Right. So, H2SO5. H2SO5. Minus 10, plus 2, plus 8. Impossible. Sulfur maximum is plus 8. So, this is called peroxysulfuric acid. If you remember well, yesterday I gave pernitric acid, HNO4, perphosphoric acid, H3PO5, persulfuric acid, H2SO5, and perchloric acid, HClO4, and I wrote this one is per only. This is only per only. But all others are both per and peroxy. Per means a little more. So, all these three contain peroxy bond. So, molecules with peroxy linkage. And now, let us look at some of the oxidation states. K2Cr2O7. What is the oxidation state of chromium? How will you find out? Minus 14, 7 oxygens, plus 2. Why? Why is it plus 2? Fixed. 2 chromiums, plus 12, each chromium plus 6, and this is okay. What is the oxidation state of chromium? Plus 6. So, oxidation state, it is not plus 12, it is shared by 2 chromiums. So, each oxidation state means each atom, per atom. Oxidation state is calculated for each atom. Then, what exactly is oxidation state? I have been teaching you so much about oxidation state without actually telling you what is oxidation state. When you win a bond, winning a bond means HCl, you should consider that chlorine has won the bond. Winning means chlorine being more electronegative, these 2 electrons, though they belong to both, we can say these 2 electrons are enjoyed more by chlorine than hydrogen. These 2 electrons always will be moving around chlorine. So, when you win a bond, when you win, your state is minus 1. When you lose, your state is plus 1. When you tie, it is 0. What do you mean by tie? A match between equal opponents. A match between equal opponents is a tie. For example, CO2. What is oxygen doing here? Forming 2 bonds with less electronegative carbon, minus 2. Minus 2. So, we can compare this with carbon is playing 4 matches with powerful opponents. How do you know who is powerful? I will give you the list of winners. I did yesterday. F greater than, O greater than, N greater than, Cl greater than, H greater than, B greater than something. You remember that? This is the order of electronegativity. You can say this is the order of winners. Fluorine is the most powerful element among all. The ratings will never change. Maybe the cricket ratings change day by day, but these ratings will never change. Fixed, permanent. Fluorine is all, wherever fluorine is, he is always the winner. Whoever fluorine plays, he always wins the match. So here what is carbon doing? Playing, I am using the word playing 4 matches with a tougher opponent. Oxygen is a second best team in the world. Carbon is nowhere in the picture. Carbon is somewhere around here. Carbon is very carbon, phosphorus, sulfur, other non-metals you will find. So first 4 you remember. So carbon is +4. So what does it mean? Carbon is playing 4 matches with stronger opponents. We believe carbon has lost those matches. And what about P4? What is phosphorus doing here? P4. What is phosphorus doing here? Forming 3 bonds with equal opponents. Tie 0, 0, 0. So the oxidation state of atoms in their elementary state, P in P4. What is phosphorus doing in P4? Playing 3 matches with equal opponents who are none other than phosphoruses. The oxidation state of P in P4 is 0. S in SA8 is 0. Cl in Cl2 goes without saying. What is chlorine doing here? Playing a match with another chlorine. Once again 0. Right? That is it. Tie. HH, hydrogen match ends in a draw because here equal opponents are playing. Okay? So Cl, once again 0. SS 0. Okay, now let us look at some questions today. Question number 1. What are the oxidation numbers of nitrogen in NH4NO3? You will get the question on your screen now. What are the oxidation numbers of nitrogen in NH4NO3? It's a very interesting proposition. You should first know this is NH4 plus and NO3 minus. There are 2 nitrogens. This is ammonium, this is nitrate. Here NH4 plus, nitrogen is -3, NO3 minus, nitrogen is +5. How did I get to the conclusion? Very simple. NH4 plus, 4 hydrogens plus 4. The net value should be +1, for which nitrogen should only be -3. You see, only -3 plus 4 will be +1. So to get +1 here, why have I written 4? 4 hydrogens. Hydrogen I told is always plus. +4 -3 +1. What about NO3 minus? NO3 minus. This is -6. 3 oxygens, you know, -6. And the net value is -1, for which nitrogen can only be +5. So what are the oxidation numbers? -3 +5. The answer is the second option. Let's go to the next question. What is the oxidation number of chlorine in hypochlorous acid? You have the question on your screen. What is the oxidation of chlorine in hypochlorous acid? Why did I teach the names yesterday? Because if you know the formula of hypochlorous acid, you can find the answer. Hypochlorous acid, HClO. You remember that? HClO3, chloric, ic. HClO2, chlorus, us. Hypochlorous is HClO. So how do you get that the oxidation state? Very simple. Oxygen is -2, hydrogen is +1, therefore chlorine can only be +1. And indeed, the structure is OHCl. What is chlorine doing here? Trying to fight a powerful opponent called oxygen. What will happen to this match? This will be lost by chlorine, because chlorine is the 4th best, whereas oxygen is the second toughest team. -2 +1 +1. Oxygen is winning 2 matches. Next question. The oxidation number of nitrogen in HN3. It is not NH3, mind you. It is not NH3. It is HN3. Hydrazoic acid. Hydrazoic acid. Azo. The sound azo refers to nitrogen most of the time. Hydrozoic acid. What do you know about hydrogen? It can only be +1 or -1. 3 nitrogens together -1. Each nitrogen -1/3. I told you oxidation state means not what you get on 3 atoms collectively. Each 3 nitrogens minus 1, 1 nitrogen minus 1 by 3. The correct answer is option number 3. Let's look at the next question. Which of the following halogens does not exhibit positive oxidation state? What a wonderful question that is. You have fluorine, chlorine, bromine, iodine. All these minus 1 to plus 7. What about fluorine? Fixed. Always minus 1, which means it never exhibits plus. What is the meaning of that? Fluorine is never plus. What does that mean? Fluorine never loses any match. Being the strongest, most powerful team, no question of losing any match. So look at that question. That's a good question. Which of the following halogens does not exhibit positive oxidation state? Fluorine. Chlorine, they exhibit minus 1 to plus 7. All kinds of oxidations. HCl, it is minus 1. ClO2, it is plus 4. Okay. HClO3, it is plus 5. HClO4, we have already seen plus 7. So we have minus 1, minus 3, sorry, minus 1, plus 3. So next question. Which of the following sequence is correct with reference to the oxidation number of iodine? Once again, a good question. I2, ICl, what are the options given? HI, HiO4. So let us first arrange in the I2, II bond. Who wins this match? Equal opponent, 0. Chlorine more electronegative, plus 1. Iodine more electronegative, minus 1. Hydrogen is plus 1. Iodine plus 7. So what is the least? Hi less than I2 less than ICl less than HiO4. So minus 1, 0, plus 1, plus 7. Where do you have Hi being the least? We have only in option number 4. Next, the reaction, let me see the question. NO2OCl, NO2OCl, in which it is clearly given that NO2OCl changes to NO3 minus, NO3 minus and Cl minus. NO2 plus, OCl minus. You should make a small correction, that is NO2 plus and oxidation state of chlorine. Okay, you don't need to make any correction, forget whatever it is. Chlorine, OCl minus, what is oxidation state? It is very clearly given that forget about NO2 plus. Why do you worry about NO2 plus? OCl minus to Cl minus. OCl minus to Cl minus. OCl minus means OCl, the minus is an oxygen. So chlorine is bonding a form with oxygen. Who wins the match? No doubt oxygen wins and chlorine is plus 1. So what happens? The oxidation state of chlorine changes from plus 1 to minus 1. Plus 1 to minus 1. Correct option is 2, option number 2. So always remember CaClOCl, which is called bleaching powder. Here chlorine is plus 1 because it is forming a bond with a metal. Sorry, really sorry. Calcium is plus, therefore chlorine is minus 1. And chlorine is forming a bond with oxygen. Okay, it's not a joke. Oxygen is strong team, plus 1. So the 2 chlorines in bleaching powder, minus 1 and plus 1. So next question. Metaphosphoric acid, it is a repetition of yesterday. Metaphosphoric acid is represented by HPO3. Next. In which of the following sulfur has the lower oxidation state? Very good question. Look at the options. H2SO4, H2SO4, H2SO3. This will be the last question. SO2, H2S. Look here. H2SO4, you already know plus 6. H2SO3, it will be, help me. H2SO3, it will be plus, minus 6 plus 2 plus 4. SO2 is plus 4, H2S minus 2. So least oxidation state means H2S. The correct option is fourth option, H2S. What is the question about? Which of the following sulfur has the lowest oxidation number? So you try and calculate, and you can take any compound at home and you can calculate whatever that comes to your mind. Thank you for today. Tomorrow we will meet with a good another lesson.